Tonight's video is part 2 of section 4.1, Antiderivatives and Indefinite Integration, and this is part 2. So your homework on this is 47 through 65 all and 77 through 80 all. On number 65, you do not have to do part B or part F. So in some of tonight's homework, or in the reading of section 4.1, it'll talk about solutions. So a solution to a differential equation is the antiderivative. There is two types of solutions. There is a general solution. That is where you have the constant of integration after you take the antiderivative. It's a general, it's not a specific. We just put in C for that constant. Or there is a specific or particular solution, and that is found by after you take the antiderivative and you have your constant of integration C, you then substitute a point into that general solution to end up getting a specific or a particular. In other words, you'll find a value for that C. So let's just do some examples again this evening. So the directions. Find the equation for y, given the derivative, and you're given a point on the curve of y. So I will do number 48. Gives you dy dx equals 2x minus 1. And when you look on number 48, you will see that it gives you a specific point 3, 2. So let's set this up so that I could take the antiderivative, take the integral of both sides. So this will end up being y. This is 2x. I'm going to increase the power by 1 and put that power in the denominator. And so this is really 1 with the x to the 0. So now it's going to be x to the 1 over 1 plus c, my constant of integration. So now let's clean that up. Y equals x squared minus x plus c. So this would be called a general solution. Let's put in the 0.32 that lives on this curve to get a specific. So again, this is your x and your y. So 2 equals 3 squared minus 3 plus c. So it's 2 equals 9 minus 3 plus c. So c equals what? 9 and minus 3 is a 6. That's a negative 6, so that'll end up being a negative 4. So my specific solution would be y equals x squared, minus x, and then my c is negative 4. That is my specific solution. Let's go on to another example. Let's see here. How about I do number 50, dy over dx equals x squared minus 1 at a specific point negative 1, 3. So let's set this up. Now I'm going to go ahead and take the antiderivative of both sides. So it's really like a 1 times dy. With just a 1, I end up with a y. This one here, I've done my variable. I'm going to increase it by 1, and that's what's in my denominator. Minus x plus c, my constant of integration. So it's y equals 1/3 x cubed minus x plus c. Then I have this specific point, which is on the antiderivative 3 equals 1/3 -1 cubed minus -1 plus c. So that would be -1, so that's -1/3, +1 plus c. So I'm going to subtract 1. And now I need to add, but I'm going to have a common denominator. So that would be 6/3. So that's 7/3. So here comes my specific solution. It's y equals, see right up here, 1/3 x cubed minus x plus 7/3. This is my specific solution to the derivative. Let us try another problem. Let us try number 54. 54 dy over dx equals 2 times the square root of x at the specific point 412. So let's set this up. Multiplied both sides by dx. Now I'm ready to take the antiderivative of both sides. That would be my y equals, here I go, I'm getting ready now. Oops, I should have gone ahead and simplified that, so let me simplify that. That's 2 times x to the 1/2 dx. So now I'm ready. Write down my 2, my x. I'm going to increase that exponent by 1 and put that exponent in the denominator plus my constant of integration. I need to multiply by the reciprocal, so that's 2 times 2/3 x to the 3/2 plus c. So it's y equals 4/3 x to the 3/2 plus c. Now I'm going to put in my specific point here, my x and my y. So it's 12 equals 4/3. So let's break that up. Put my 4, that 1/2 means a square root. And then after I take the square root, I'm going to go ahead and cube it. So let's see, the square root of 4 is 2. Now I'm going to cube my 2. So that would be times 8 plus c. I'm running out of room. Let me come on up here. That's 12 equals, so what is that? That is 32/3? Yes. 32/3 plus c. Now I'm going to subtract that. And once I get myself a common denominator, I think I will be done. So let's see, I need a denominator of 3, so that's 36 minus 32/3 equals c, so that is really 4/3. So now my specific solution is y equals, again from here, 4/3 x to the 3/2 plus 4/3. There is my specific solution. I will try one more for this evening. And let's see here. How about I try one of the linear motion problems. You have word problems 77 through 80, which is your linear motion. So I think what I will do is I will do problem number 78. No, maybe I will not do that. Let's see here. I guess I will just do 77. 77. You are given the position equation. And that time is from 0 up until 5 seconds, including 5 seconds. Part A is find the velocity and the acceleration. So we know how to do that. So let's see here. So for the velocity equation, I'm going to take that first derivative. So this feels like stuff back in chapter 3. What is that? 12t plus 9? And in case they ask me any questions, if I need to find the critical numbers, I might as well go ahead and do that factoring now. Let's see, what am I going to get here? A t, a 3, a 1, a negative, a negative. Okay, so just in case. My acceleration equation is from taking the velocity equation and taking its next derivative. So that would be 6t minus 12. Okay, so here are my two equations. I found part A. Let's see what part B has to tell me. So I'm supposed to find the open intervals in which the particle is moving to the right. Particle moving to the right. So if you recall, back in chapter 2, that means when my velocity is positive. So my velocity is right here, and I need to test out values to see where it's positive. So I'm going to find my critical numbers. I'm going to set that equal to 0. So my critical numbers would be t equals 3 and t equals 1. Again, my t is only from 0 to 5. At 1 and at 3 are my critical values, so I'm going to have a test point of 1/2, of 2, and of 4. And this is on my velocity equation. And so wherever it's positive, oops, sorry about that, wherever it's positive, the particle is moving to the right. So let's see, velocity of 1/2. Let's see, my velocity equation. I just lost it. There it is. It's back on the screen. Is 3 1/2 squared minus 12 1/2 plus 9. So that will produce 3/4 minus 6 plus 9. And so it looks like it's going to be mostly positive. So I'm going to put positive in there. Next, the velocity of 2, and actually it might be easier if I put it in this equation. 3, 2 minus 3, oh yes, that's much better. And what would that produce? 3 and a negative 1 and a positive 1, so that produces negative here. And in the last test point, velocity at time 4. Again, I'm going to put it in this equation. So 4 minus 3 is 1, and 4 minus 1 is 3. That's going to produce positive answers. Again, what are the open intervals in which the particle is moving to the right? In other words, where is my velocity positive? It's positive here and here. So the answer to this would be the interval from 0 to 1 and from 3 to 5 seconds. That is where it's positive. When the velocity is positive, the particle is moving to the right. There is a part C. Let's take a look at that. I need to find the velocity of the particle when the acceleration is equal to 0. Well, let's see here. My acceleration problem is right here. So let me copy that down here. My acceleration is 6t minus 12. So let's see when this is equal to 0. Zero equals 6t minus 12. And so sorry. That would be a positive 12, and that would be t equals 2. So for my acceleration from 0 to 5, I need to go back and grab my velocity from 0 to 5. In fact, I don't need that one. Sorry about that. I just need my acceleration, and it as my critical number is at 2. And so the acceleration is 0 when t equals 2. So let's go ahead. Oops, I'm supposed to find the velocity. When? At 2 seconds, because that's when the acceleration is 0. At 2 seconds, my acceleration is 0, so let's go find that velocity at 2. So I didn't need to do test points. I needed to read my directions just a little bit clearer. Find the velocity when the acceleration is 0. What's at 2? Where is my velocity equation again? It is, velocity is 3 times t minus 3, t minus 1. So at 2, it is 3 times 2 minus 3, 2 minus 1. So it's 3 times negative 1 times 1, which equals negative 3. That's it for this evening. Thank you.